All right. So, like I said, a little bit weird. We're going from Unit 4 to Chapter 8. We're going to call this Unit 5 just to keep the order. But we're going to talk about systems of linear equations. Now, this is going to be a really important 2 lessons for us. Today is A, tomorrow is going to be B. This is a really important couple lessons for us because in Math 1 next year in high school, you're going to be learning about systems and you're going to take it a little bit further, okay? So we really got to make sure we understand how systems work right now as like our easiest lesson groundwork is laid so that when you go on to high school next year, you're super prepared to take systems to the next level and learn more about them, all right? So this is not just a, I don't care about this lesson. This is I care about my future. I'm going to care about this lesson, okay? So, a system is just 2 linear equations. Could actually be 3 or 4, but we're just going to stick with 2. 2 linear equations that work together. What does that mean? Well, let's take a look at what it looks like. Here's a system of linear equations. Right? Yeah. What's the formula that both of these equations are in? Can anyone tell me? Yeah.
Y equals x minus
mx.
Very close. Y equals something. Rowana, what is it?
Y equals mx negative 4.
Very close. Y.
equals y.
Yeah, that's right. Plus b, right? Y equals mx plus b. Y equals m here is 1, x plus b. It's our slope-intercept formula, right? Or our linear equation formula. Now, we may not always have an equation that's in this form. This is where we're going to start to get a little bit a different work here. We're going to talk about something called standard form. Go ahead and write down our formula for standard form. Goes by the name of ax plus by equals c. Yes? We can talk about that later. A, B, and C, make sure they are capital. Okay? If you write them as lowercase, believe it or not, it actually means a different thing in math. Okay? So make sure your letters here, A, B, and C, are capitalized, but X and Y need to be lowercase. We're not going to get into the specifics of why, because I don't want your brains to explode. So let's just keep it at that. A, B, and C need to be capital. Okay? Okay, guys, we should be writing, not talking. And with this formula, A, B, and C are what we call constants, right? Everybody say that with me. Constants, okay? What does constant mean? Kenny, what is constant?
They do the same thing constantly, but I get it's that's the word.
Exactly, yeah. So we're talking about like the same. Repetitively, right? It's doing the same thing. Thank you. Yeah, go ahead. Adibula, head on over with Nikki? Vicky? Sorry, Vicky. I apologize. My bad, Vicky. She doesn't have her backpack. I can't tell. So, A, B, and C are all numbers. Constants, like Kenny said, it means the same, right? And the reason why we call constants numbers is because the opposite of constant would be variable, right? A letter in math can be anything. X could be 2 in one problem, but negative 3 in another problem. Numbers are the same number no matter what equation they're in, right? 3 is 3 and 4 is 4. There's no debating that. So that's what we mean by constant here, okay? And then finally, let's get our last word written down, and that is solution. And a solution is just an ordered pair that makes a true statement when plugged into a system of linear equations. I'll give you guys time to write that. With the way you guys are angled, can everyone see okay? Is there anyone that's at a weird angle?
My neck hurts.
Okay, I got you. Do you want to move over there to group 6?
No.
Okay. I sat down in all the seats this morning to try and see if the sight line was okay, but if someone's too tall or something, just let me know after class so I can get you moved. But
I'm not too tall. I never will be too tall.
you don't know that.
I think I'm too tall, but
You think you're too tall?
Disagree.
It all depends on what you want. If you want to be tall or not.
6 foot one day.
You will. Keep in mind, eighth grade gentlemen hit their growth spurts a lot later, right? I didn't hit my growth spurt till like junior year of high school.
Real what?
Yeah.
Junior in high school.
Yeah, I was like, I don't know,
how tall are you?
5 foot, like maybe 4 or 5 in middle school. In the beginning of high school, 5'5", and then I grew like 6 or 7 inches over summer, I think.
Oh yeah, sure.
Or like over like 4 months or something like that.
Because I'm like 5'5".
Yeah, you'll get there eventually. Anyway, sorry, we're off topic.
I'm gonna get my shirt.
My dad's like 6 foot.
Oh yeah, you'll be fine. You'll be
I'm
okay.
trying to be like 6'1".
All right, sorry about that. Sorry about that. Let's take a look at what I mean by a true statement.
Not exactly. He's like taller.
So a true statement is going to look something like this. 4 equals 4. Give me a thumbs up if you think that's a true statement right there. 4 equals 4. Yeah, Hannah's got her thumbs up. Mason's got his thumb down. That's okay. 4 equals 4, right? Like I said, we can't debate that. It's a fact. 4 is equal to 4. But a false statement, the opposite of a true statement, may look like this.
2 plus, oh, 9 plus 10 is 21.
That would be a false statement, yeah. A false statement would be 4 equals 3. Does 4 equal 3? No. Is 4 ever going to equal 3?
No.
No. Only if you subtract 1 from it, right? But then it's not 4 anymore. So here's how we're going to denote a true statement and a false statement. A true statement is going to get a check mark next to it like that. Okay, fellas. Stop talking. We got to focus. Max? Yeah. So true statements, we're going to put a check mark right next to them. Whenever we see 4 equals 4, 10 equals 10, -2 equals -2, if we see the same number on both sides, that's a true statement. We'll give it a check mark. Yeah. What's up? I do not, unfortunately. No, I'm sorry. And whenever we see a false statement, like 4 equals 3, what we're going to do is put an X next to it like that. Okay, that tells us that that is not a true statement. That one's false. All right, so let's get into the actual work here. I know we didn't talk too much about standard form, but we will once we see this example. So let's get our steps written down on how we're going to find out if an ordered pair is a solution to an equation. Step 1. Plug the x coordinate into the equation for x. We can go ahead and say, and we're going to plug in the y coordinate for y. You said you can't see?
He said my pencil.
Oh, he said my pencil. I see.
Your pencil grip.
So today we're going to be looking at equations that are in standard form. ax plus by equals c. Once we plug in those two numbers, which we're used to doing, we did that during Matho, right? Plugging in two numbers, simplifying both sides of the equation, and then seeing what you get. Only here, we're not going to end up with something like x equals 2. We're going to end up with something like 4 equals 4, or 4 equals 3. So the second thing we need to do is simplify using PEMDAS. And then actually put using PEMDAS in parentheses. And we're going to say simplify the left side of your equation. As we'll see, there's only one side that we're even able to simplify, but it's always going to be on the left, so we might as well be specific. And the third step is very simple. All you're going to do is ask yourself, is this statement true? Is our statement true or false? So only two outcomes, luckily. If our statement at the end is true, then yes, that ordered pair is a solution to the equation. If we get a false statement like 10 equals 1, right, that would not be true, that would be false, then we can say no, that ordered pair is not a solution. Yes. Go for it, yep. So let's take a look at example A. Example A is going to ask us, is the ordered pair 2, 4 a solution to the linear equation in standard form of 5x minus 2y equals 2? So we got an ordered pair. We got an equation here in standard form. Let's go ahead and go through our steps. What's step 1? What's our first step going to be? Azalea, what's our first step? That's right. We're going to plug in x for x and y for y. in 2 comma 4, which one is our x value?
2.
Everyone's saying 2. I agree with that. 2 is our x value, and that makes 4 our what value?
1.
Y value, right? So we're going to plug 2 in for x, and we're going to plug 4 in for y, just like that. I'll zoom in a little bit so you can see better. So when we're substituting 2 numbers in, or when we're plugging in 2 numbers, right, we're going to replace those variables with the numbers. Now, because we've got coefficients, 5 and 2 here, our a and our b, we're going to want to exchange those variables out for parentheses, right? Just like we do in the slope formula, just like we do in the math O formula. So our x value was 2. We're going to plug 2 in right there. Our y value is 4. We're going to plug 4 in right next to it. Sorry. Now we're going to solve using PEMDAS, right? Hold on, that was step 1. Now step 2, we're going to solve using PEMDAS. So, what is the first thing we need to do if we're going to use PEMDAS, Azalea? Yeah, we're going to do 5 times 2, and we're going to do 2 times 4, right? So here's the deal with this. I know I've been saying, a lot of our lessons have been open to your interpretation, whatever you're more comfortable with doing. With this specific lesson, I want you guys to do it this exact way on the worksheet you're about to get, okay? I want to see this equation written out like this. I don't want to see just answers. Okay, this is a very procedural thing that I want to see. 5 times 2 gives us 10. 2 times 4 gives us 8. And now the equation that we've got is 10 minus 8 equals 2. Okay, and we can see already that's a true statement, but let's finish solving via PEMDAS. 10 minus 8 is going to give us 2, right? So our step 3, we see our final, or our resulting statement here is 2 equals 2. We know that that is true. We're going to give it a check. And then we're going to say yes. Because our question was, is this point a solution?
Yes.
We plugged it in, we simplified it, we got a true statement. Our answer to that question then is just yes. Yeah, we got time. We got half an hour. So let's do example B. Is negative 2 comma negative 3 a solution to the equation? Let's see, what do we want to do? 2x plus 4y equals 6. Let's go 2x plus 4y equals 6. What's our step 1? First thing we got to do. Noah?
Plug x to x and y.
Plug in x for x. Negative 2 goes right there. Plug in y for y. Negative 3 goes right there. We're going to rewrite them as parentheses. Rewrite all of our constants around it. Let me write those numbers in place. -2, -3. Now this is another reason why our parentheses are so valuable, because when we have a negative coordinate that we're plugging in, we don't want to get confused and think this says 2 minus 2 plus 4 minus 3. We don't want to do that. We want to multiply these two things, and then we're going to add them together. So step 2 is we're going to multiply. What's 2 times -2 going to give me, Azalea? -4 plus, what's 4 times -3 going to give me? Azalea, go for it. -12, perfect, equals 6. Okay, we kept that plus sign in the middle, but now we see that we're adding a negative number. So what do those two signs come together and form? Ruwana? A negative sign, right? This plus and this minus here just form a minus sign. Oh, you can't see that at all. Right? Those form a minus sign. So really we've got -4 minus 12. And what's that going to give us? -16, right? Does -16 equal 6? No, absolutely not. Our answer here is just going to be no. Like I said, your work should look exactly like these two examples right here. See how we had a different ordered pair and a different equation, but the examples look pretty much exactly the same. So each of your problems on the worksheet, I want to look exactly like this. I don't want to just see yes, no, no, yes, yes, no, yes. All right? If that's what I see when you turn it in, it's just going to be incomplete, and you'll see that in Synergy. Yeah?
Is there a backside?
There's not. 10 questions on the front, that's all. It's Thursday. I'm not going to give you a backside. We don't have enough time. Absolutely. So here's the beauty about the groups now. No one has to get up. You can talk to 3 people right there. So we're not going to be getting up and moving around. You've got 3 resources right next to you to work with, if you so choose.
What happens if one of my researchers are asleep?
Okay. I'm going to make a note of that.
That's a good idea.
So I'll take this. I'll remember.
Really?
I'll take a picture.
No, can I have my bracelet back?
Actually, forget everything I've just said.
I want to see this one. When it's cold.
Oh, cool. Thank you for letting me know. I really appreciate that.
I look so.
Sorry.
I look so different.
That's crazy. That was his last name.
Oh, my 7th grade.